Solve for x, check for extraneous solutions. When we have a radical, we can create accidental fake answers, and we need to verify that they are good or not good answers from the original equation. Right now, x is on both sides of my equation. However, the most important thing we need to get rid of is that radical because it's the most pesky. So we need to square both sides. Since this is a square root, I need to square both sides. And notice how I'm wrapping the entire side of the equation in parentheses. I need to square the entire thing on both sides. That would cancel out the root on this side. I would just have x plus 12 equals x plus 6 squared. If I'm going to square x plus 6, I can't just say x squared and 36. I need to write x plus 6 times itself. X plus 6 squared would be times itself, like so. If I multiply that out, I'm going to have 4 terms because we have a binomial times a binomial. So I got a little bit of scratch work to do in between here. If I were to multiply out those two things right there, I would have x squared plus 6x plus another 6x plus 36. Got a lot of junk that comes out of that. All right, we are solving, so we need to get everything to one side of an equation. That way we have an equals 0 somewhere in there. Since most of my stuff is on the right side, I'm going to minus off this x, and I'm going to minus off 12 from both sides. So I need to put a minus x and a minus 12, like so. This makes all of these terms go away. These all cancel out so that I have a 0 on this side, equals. I've got quite a few like terms on the right side. Let's make sure we don't lose track. All of these right here are just x's, so I can combine those together. And then I can combine together 36 and minus 12. I still have x squared. 6 plus 6 plus negative 1 x's would make 11x. And then 36 minus 12 would make 24. All right, I have everything on one side of the equation so I can see what I'm dealing with. Looks like we're dealing with a quadratic, and this one is a trinomial, and I bet you this thing's probably going to factor. So let's turn this into factored form like this. All right, everything is positive, so that helps us a little bit. I know that my factors will be all positive. Factors of 24 that add to 11. I have 1 and 24, 2 and 12, 3 and 8, 4 and 6. There's quite a few, actually. I think 3 and 8 are going to be our factors here. So I'm going to say x plus 3, x plus 8. When we solve a quadratic that's in factored form, we factor it like we just did, and then we need to say the opposites of those. My solution for that first factor is going to be negative 3, and my second factor is going to be negative 8 for a solution. So we have two possible answers. One of them could be extraneous because we accidentally might have created some false answers, so we do need to check both of these. So I got some checking to do. That's awkward. Okay, I need to check x equals negative 3, and I need to check x equals negative 8. We're going to see if any of those answers are actual valid answers. All right, remember to do this, we start with the original equation. Instead of x, I'm going to plug in the number that I solved for. So I'm going to use negative 3 in these spots. I'm going to go ahead and set up the next one just so I can solve it in a minute. The second one we're going to try is negative 8. Okay, let me clean up the one that's on the top. If I try to clean up square root of negative 3 plus 12, I could just say that is square root of 9. The right side would be a positive 3. Well, square root of 9 is 3. That is true. So I have 3 equals 3. That is a true solution. So we are allowed to accept x equals negative 3 as a valid answer. Let's check the one on the bottom. Square root of negative 8 plus 12. That would be square root of 4 if I put those together. Negative 8 plus 6 on the right side would be negative 2. If I take the square root of 4, that's going to be positive 2. Well, that does not equal negative 2, so I'm not going to accept x equals negative 8 as an answer. I'm going to say reject x equals negative 8. And I'm not going to box that one up because I don't want to accidentally think that's an answer. The only valid answer that comes out of this is x equals negative 3. It just appears that negative 8 was an answer when we did our work.